question 1, this one is actually not a lot of work in it, but it's a good one to understand what's going on. So it says, consider this polynomial and the completed synthetic division. So they've done all the work. The above results indicate that what value is a root of p. It's because you have a 0 for a remainder. That's what you want to see there. And so whatever you're dividing by, the 4 is a root. So 4 is a root, and I'm not going to write all that in the notes. There you go. And so based on the above result, p can be factored as, so they want you to include your divisor, which is actually x minus 4, and then the polynomial that's left. So we were at third degree, so now we're going to be at second degree, so 3x squared plus 9x minus 12. And we'll just look rather than type it in. So we're good there. That's what they wanted you just to see. And to notice, if you get 0 for remainder, which is your goal when you're working on these, then this piece is a 0 or a root. Right, the next questions, and I think I can fit these on the same screen. They want us to find all the possible rational zeros. This can get annoying when you have to put these in, so just be patient with it. Not having a plus and a minus symbol is a real drawback on these. But your possible rational zero theorem, and I should probably write the problem out here, doesn't tell you what the roots are. It tells you about possibilities. And I'm just going to call them PRZ. That's what possible rational zeros. And so the formula is going to be, it's plus or minus. It is factors of the constant term over factors of the leading coefficient. And this time our leading coefficient is a 1. That does give us some information. It means we're not going to get any fractions that are zeros. And so that'll be helpful on some other problems. So let's go ahead on this problem. This one is not too bad. We want to list the factors of 40, and we've got the plus and minus. So we have 1, we have 2, 3 doesn't go into 40. We have 4, 5 does, 6 does not, 7 does not, 8, 9 does not because we don't have a 3, and 10, and this actually has turned over because 5 times 8 or 8 times 5, 10 times 4, and so the next one that's going to work is going to be 20 times your 2 and 40 times your 1. And the formula says over the factors of the leading coefficient. It's 1, so it doesn't matter here. I'll just put it for, so we have the whole formula there. So when we do the answers, we've got all of these positive and all of these negative. These are possibilities for the zeros to be. And there you go. I am not about to enter all those. Okay. So let's look at 3. And this one we have a different leading coefficient, so that's why I wanted to go ahead and do one more. So we have p of x equals negative 3x to the 4th plus 15x cubed plus 7x squared minus 19x plus 15. Right, same kind of question. Find your possible rational roots or possible rational zeros. And so it is plus or minus factors of the constant term. So 1, 3 goes in there, 5, and 15 over factors of the leading coefficient. This time we do have a number here, so factors of 3 are 1 and 3. So you are going to have some fractions in this list. You do have to clean this up. So first of all, if we take all of them over 1, we're just going to get these integer numbers. So plus and minus 1, 3, 5, and 15. And then we have all of them over 3. So 1 over 3 gives us 1/3. 3 over 3 is 1. We don't have to include it again because it's already in the list. 5 over 3. And 15 over 3 gives us 5, so we don't need to include that again. So these are our possible rational zeros. This time you can get fractions for an answer. And so they have 1, they have 1/3, then they have the negatives, 3 and -3, 5, 5/3. So they have the same things that we have. Any question? All right. I'm going to have to just adjust this headset, so I hope it won't get real loud just for a second. It's falling off. Okay. All right. 4, I'm going to do, actually, that's not the one that was crazy. One of them had ridiculous number in it. Oh, we'll do 4. We'll find the ridiculous one in a few minutes. Right, this one is just out of order. So you need to switch the order. I'll write it in order first. And so you want to just switch and go to descending order. So x cubed should be first, minus x squared minus 22x plus 40. And that really is the only thing different. Well, we're going to find zeros at the end. So for the 40, our possible rational zeros, which is our first answer, and we actually just did a 40. So it's going to be those same ones, so plus and minus, and our leading coefficient is actually a 1, so we're just going to have the ones on top. So 1 goes into 40, 2, 3 does not, 4 does, 5 does, no 6, no 7, 8, 10, 20, and 40. So those are our possible rational zeros. That would be the first thing in the list, so positive and negative. Then they want us to find the zeros. Now, if you did not have a graphing calculator, you have to just start guessing. This was back before graphing calculators. You would just start guessing out of these possible rational zeros and doing a bunch of synthetic division. You could do a whole page before you find it. And what if it had complex zeros? Then you've wasted a lot of time. So we're not even going to go that route. We will have to do some synthetic division, but we're going to use a calculator first to help us out. And that is what I suggest you do. If you don't have a graphing calculator, get really comfortable with Desmos.com because it will show you the zeros also. And I will make sure you can use that site on your test. All right, so what we want to do is, oh, and the calculator doesn't like my pen. So we want to enter this, and we want x to the third minus x to the second minus 22x plus 40. And we're going to hit graph, and I think I have to fix my window because I had it on a different setting. So to fix your window back to normal, you can do zoom standard, which is 6. Right, and what I care about are these x-intercepts. You need to check each one and make sure that they really are zeros. So this would be -1, 2, 3, 4, -5. Now that should be in our list. If it's not going to work. But do second calc and choice number 1 value and plug it in. What do we say? -5. And we hope we get 0. So we did. So we have -5. And we checked it on our calculator. And then this one looks like 2. 2 is in our list, so we will do second calc value just to verify that it's not off slightly. Right, and so 2 works from our calculator. And the other one looks to me like 4. So second calc value and number 4, enter, equals 0, perfect. And you're supposed to get as many zeros as your degree. That's important so that you make sure you have all of them. Our degree is 3, the highest exponent, so we have the zeros. So we don't have to do any synthetic division on this problem. So we'll just look at our zeros, and there they are. And that is all I would do. I would not force any extra work there. All right, we'll skip 5. It's kind of the same thing, and you're going to find the zeros from the calculator. We'll go to 6. And so we're going to use the rational root theorem to list all the possible rational roots. So first of all, we need to put it in descending order. So I'm just going to write it in descending order. X cubed should be first, minus 5x, minus 2. So we don't have a lot of possible zeros here. So we're going to have plus or minus factors of 2. So 1 and 2 over the leading coefficient factors, which is 1. So we're good there. So our choices are 1 and 2. And I would go ahead and go, of course, positive and negative. Let's go ahead to the calculator. And we'll type in, so x to the third minus 5x minus 2. All right. And so this is where your rational zero possibilities is helpful. Okay, I see one that looks like it actually goes through an integer. So I think -2 from the calculator. So let's check it and make sure. So we're going to do second calc value, and we're going to put in -2, and that is a 0. So that one works. Notice the others, they're going through here in between, so it would be like a fraction. But there are no fractions in our list of possibilities. And what that says to you is that you're going to get answers that have radicals on them. So they're irrational numbers, and you're going to need the radical form. If it just asks you for a decimal approximation, you wouldn't have to get the radical form, but because it will give you a decimal approximation for these. But you know they're radicals because there's no fraction in the list. Okay. So we will do synthetic division on this one because we know 1, 0. We want to get this down to a quadratic. So it won't be so bad. So we got 1 for x cubed. Make sure you put in your 0 for x squared minus 5 minus 2. Skip a row. And we'll bring down. So multiply 1 times negative 2 is negative 2. This will give us positive 4, negative 1. And this gives us 2, 0 remainder, which is what we expected. So from here, we drop 1 degree, so we have x squared minus 2x minus 1. And we can set that equal to 0 and solve. Was it okay on the video from last time when I switched and made the screen big? Did that turn out nice? Can anybody tell me? All right, I'm going to try it on here, and if it looks funny, jump on the chat and let me know, okay? That way I can do the rest of the math on the same one. All right, so that's full screen. Does that look okay? Okay, perfect. That'll be better for us because we can go ahead and do our quadratic formula over here. We want to solve this to find the other 2 zeros, and it will not factor. We already know that. So our A is going to be 1. B is negative 2. And C is negative 1. So quadratic formula, x is equal to negative b. I'm going to plug in as I do it. So negative b, it's already negative, so that will be a positive b plus or minus the square root of b squared minus 4 times a times c. Whole thing is over 2 times a. And we can clean up. So 2 plus or minus. This will give us 4. And we'll multiply here. This is going to give us a positive 4. And this is over 2. So we have 2 plus or minus square root of 8 over 2. Square root of 8 you can simplify on the side. Break it to primes. It has a 4 in it. That's your perfect square. So 1, 2 is going outside. 1, 2 is left inside. It goes for those. So we have here 2 plus or minus 2 times the square root of 2 over 2. You have to always watch with these in this triangle that is around your plus and minus. They all have a common factor. So we're going to divide by 2 there. You will have to write this one. So we'll end up with 1 plus or minus square root of 2. This will give 2 of our zeros. Don't forget your 0 you had at the beginning. So for all of our zeros, we have negative 2, and I'm just going to go ahead and use the plus and minus here, even though you won't be able to type that. All right, I think it lets me keep that half of the screen when we go back. Good. So possible rational zeros, it was +1 and +2 and -1 and 2, which is on the screen earlier. And here are our zeros. So we're good there. Any question there? All right. We will also do problem 7. That one I think is a good one to have a look at. This is the one that had a ridiculous number for the end. But it's a good one to work through. And I will take the time to show you how to write out all those possible zeros, because 320, that just seems a little crazy. Okay. So it generates these problems, and so that's why sometimes you get big values. All right, so our first question is for possible rational zeros. One nice thing that I can see is your leading coefficient is 1. So that's going to be a 1 in the denominator. There's going to be no fractions. All right, so we'll find the possibilities for 320. Right, and I'm just going to go down the list for 320. So I'll try to do it kind of at this edge so I'll have more space. All right, so I'm going to just start dividing into 320. So 1 times 320, and then I'll do 2. So just on your calculator, you're just dividing, because you know it's a big chore when you first look at it, right? Test of 3. 3 doesn't go. You get a remainder. Test of 4. 4 works. 4 times 80. So see, this is coming down pretty fast, right? Test of 5. 5 is going to work because it ends in 0. So it is 5 times 64. 6 doesn't work. 7 doesn't work. 8 works. 8 times 40. And then it goes to 10. 10 times 32. 16 is the next one. 16 times 20. And then after that, it's going to turn around. When it turns around, you can stop. So going up the list until actually you hit the square root. That's where it turns around. So it wasn't so bad. For your possible rational zeros, remember you have plus and minus with all of these. So 1, 2, 4, 5, 8, 10, 16, 20, we got the 16, we got the 20, 32, 40. I'm just going back up this side. 64, 80, 160, and 320. Right. Over 1, because your leading coefficient's a 1. So those are our possibilities, and no fractions there. All right, so next I would pull up the calculator. So this is the first piece of the answer. There you go. Should be right. But now we want the actual zeros. So we're not going to guess. We are going to go to the calculator, and we're going to enter this. So x to the 4th minus 2x to the 3rd plus 24 x squared minus 208x plus 320. Graph. All right. Now, our degree is 4. That tells us we should get 4 zeros. If we have the end behavior of this graph, we are only seeing 2. That's an indication to you that you have some complex zeros because they're not going to show on the graph. Let's go ahead and double check these two first. It looks to me like a 2 and a 4 from the graph, but we'll verify. So this is from the calculator. Right, so we do second calc value. And we plug in a 2 just to make sure it's not off. Good. And we'll do it again. So second calc value with the 4. Perfect. So these 2 zeros work. And then we'll go to synthetic division. So I'm going to make it big again. And we'll do the synthetic. So we'll use a 2 going into 1, -2, 24, -208, and 320. Draw your line, bring your first one down, and I should have written smaller there. All right, so 1 times 2 is 2, and this gives us 0. 0 times 2 is 0. 24. 24 times 2 is 48. And this gives us -160 times 2 gives us -320. And that gives us a 0, which is what we expected, right? What you want to do with your next one is divide right into this. You don't want to start over because you want it to come down a degree each time. If you start over, it would still keep you at degree 3, which is where it is right now. So we will divide into this row, the 4, and so 1 times 4 is 4. So 4 4s are 16, and this one gives us 40. 40 times 4 is 160, and we get a 0 there, which is good because that just verifies that's a 0. This is what we really wanted out of that problem, and it is now a quadratic because this was 4, this was 3, this is 2. So we have x squared plus 4x plus 40 equals 0, and this is where we're going to go to quadratic formula. So, and we are expecting complex zeros, so the i's. So our a is 1, our b is 4, and our c is 40. So I'm going to start here. So negative b, so -4 plus or minus square root of b squared minus 4 times a times c all over 2 times a. Right, this gives us -4 plus or minus 4 squared is 16. And this is minus 160 over 2. And we'll go down one more level here. -4 plus or minus square root of -144 over 2. And then we'll go up. Right? And so 144 is a perfect square. Square root is 12, and we have to take out the I. So this gives us -4 plus or minus 12i over 2. Around your plus and minus, these are all even. You have a common factor of 2. So divide that out. So it gives us -2 plus or minus 6i. That takes care of 2 of the zeros that are not going to be on your graph, and the 2 and 4 are our other two zeros. So I'm just going to put this here. 2 and 4 are our other two zeros. We'll go back. And just to verify, 2, 4, negative 2 plus 6i, and negative 2 minus 6i. Any question there? All right. The next few questions ask us about making the equation. All right, so this was our work for finding the zeros. And let me get a new page. So question 8 tells us we have an nth degree polynomial with the following conditions, right? P is of degree 3. That's important because that tells you how many zeros you're going to get, right? 5 is a 0 with multiplicity 2. One is a 0 of multiplicity 1. And they tell us P of 2 equals 36. What this helps us to do is find the coefficient in front of the polynomial. So what we have to do is get the factors, and for 5 to be a 0, the factor is x minus 5, and because it's a multiplicity 2, I have 2 copies. For 1 to be a 0, it's x minus 1. All right, so I'll write these all together. So we have an a, which we don't know what it is, x minus 5 squared, and x minus 1. And now we're going to use the last condition to help us find the a. So this whole thing is equal to 36 when we plug in 2. So this is the y, this 2 is the x. So 36, keep the a, plug 2 in for your x's. Right, 2 minus 5 is a negative 3, and negative 3 squared is a 9. 2 minus 1 is 1. So we have 9a equals 36. So divide by 9, a equals 4. So our polynomial is going to be p of x equals 4 times x minus 5 squared times x minus 1. I'm going to see if I can get away with that answer instead of multiplying it out. It hasn't multiplied out in the key, but I think I can get away with that. If not, we'll multiply it. If so, it saves you a lot of trouble to know that that happens. Okay, it does accept that. That will save you a lot of work from doing the algebra. You could certainly do the algebra. You would multiply this times itself 2 times, and then times the x minus 1 and times the 4. And I can show you the answer. I'm just going to put ... because I'm not going to do all that work. It is 4x cubed minus 44x squared plus 140x minus 100. And that is what the key will show. But play it smart and just go the first route. You can avoid a lot of algebra mistakes that way. All right. Just want to look back at my time. We're pretty good. We'll go ahead and do 9. I had it marked as optional. but since it let me enter the answers like that, it's the same kind of question. All right, our degree is 3. Seven is a 0. Multiplicity 1, -6 is a 0. -4 is a 0. And that's all the zeros we're going to have. So our function, and we'll still have to worry about finding the a, it'll be x minus 7, x plus 6, x plus 4, and then we have to use the last condition, p of -1 equals 600. So when we plug in -1 all the way through, we're going to get 600, and that will help us solve for a. So -1 minus 7, -1 plus 6, and -1 plus 4. So this gives us a -8. This gives us 5 and 3. And so that is 40 times 3. So that is a -120. A equals 600. So divide by -120. And I think it gives us a -5. So then to put your answer in, just replace the a with the -5 and don't multiply it out. I'll go back onto this one. And we can type it in. -5 parentheses x minus 7 parentheses x plus 6 and parentheses x plus 4. And click outside, submit. There we go. They accepted it. If you multiplied it out, this is what you get. Okay. So I'm really happy not to have to put that in. All right. We'll look at 10. 10 has some complex zeros. So it says P is degree 3. -2 is a root. 4i is a root. Right, and there's a theorem that you have to know here because they only told you 2. And the theorem is if you get any complex roots, you also get the conjugate of that root. So the conjugate, if you're in binomial form, it's a plus bi, and then it would be a minus bi. So your a here is 0. So the other one that will be a root from that theorem is minus 4i. So you had to know that part. Complex roots come in conjugate pairs. All right, so and this condition P of 3 equals 250. All right, so this will be a factor of x plus 2. This will be x minus 4i. This is minus a negative, so it will be x plus 4i. And then we will do We'll plug in the 3. This will equal 250. So that we can find our A. Right? And so we have 3 minus 4i and 3 plus 4i. And this one we will have to multiply out in order to get the A. So this gives us a 5. So we have 5A. And here, if we multiply these, right, it's a FOIL. 3 times 3 is 9. When you multiply conjugates, what happens is the outside and inside cancel, but we'll do it just to show. So we have plus 12i minus 12i and minus 16i squared. Right? These go out. I squared, remember, is negative 1. So this gives us plus 16. So 16 plus 9 gives us 25. So we have 5a times 25. So we have 125a equals 250. So divide by 125. So the a will be 2 on this one. So we can go back here and put in, I believe, this other form. 2 times x plus 2 times x minus 4i and x plus 4i. I believe they will accept that. If they don't, we'll multiply it out. So 2 x plus 2 x minus 4i it's probably not going to like that. X minus 4i. Okay, it didn't give me an I on here. So it's probably going to scream about that. I get 3 chances, right? Okay, so on this one with the i's, it's not going to take that form. So we will have to multiply this out. So I would do these two first, because you're going to get canceling. So you have x squared plus 4xi minus 4xi, and this will be minus 16i squared. And I squared gives you negative 1 times negative 16 is plus 16. These go out. So x squared plus 16. And you remember those, that won't factor. And so that's the kind of answer you get out. Actually, it may take this form. We'll put this form in. So I get 3 chances, right? Okay, good. So it didn't make me multiply it all the way out, but it did not like the i's in that function. And the key will actually have it all multiplied out, I believe. Yes. All right, let's see how my time is going. Let's go to 12. And if I have time at the end, I'll come back to 11. I had a sign error on it. When I worked it, but I want to get to 14, so let's do 12. All right, and they say completely factor it and find all the zeros of the polynomial. And so I went straight to my calculator. I should use the one on the screen so that you can see it, right? So I'm actually finding this piece first and then going to work backwards from the zeros to get your polynomial, which is what you have to do, right? Because this is not going to factor for you. All right, so we have x to the third minus 10 x to the second plus 13x plus 24 graph. Right, and when we check these zeros, so we're checking -1. We should have 3 zeros from our degree. So second calc value and -1. That one works. Looks like a 3. Also works because it's given us y equals 0. And 3, 4, 5, 6, 7, 8. And 8 is a factor, so it's a possibility. It's a factor of 24. So second calc value 8, enter. There we go. So we're good there. So our factors are going to be x plus 1, x minus 3, and x minus 8. Our leading coefficient here is 1, so they didn't give us anything else to work with, so we should be okay and not have to find an a there since it was 1 on the original. So we have our zeros and we have our factors, and here, because they ask for linear factors, they're letting you put this, even though they also let us up there. And our zeros, 3, -1, and 8. So very good. But remember, your calculator came first there to help us get those zeros. All right. 13. And actually, I didn't finish that one. Let me do 14, and then I'll go back to 13 and 11 if we have time. All right. Because I know 14 has some different ones. And I know if you watch the video on this one, and Mrs. Allen made this video down here, She takes a lot of extra steps that I kind of skip of listing the possible rational zeros. Unless it asks for that, I don't really do that unless I'm questioning and I have a fraction. So we want to know the zeros and we want to make the linear factors. My first step would be go to your calculator and let's see what we can get out of it. So we're going to clear that out, put this one in. And you should retry all these on the calculator that I do, or, you know, try it yourself when you are doing it. So, and my things have quit moving here, so that is all I have. If I have the whole picture, so that's a clue that you have some irrational, I'm sorry, not irrational, some complex zeros. So let's check this and this is not the problem I worked. Okay, Mrs. H will have to go with the flow here. I worked a different problem. I must have hit enter on it. Hopefully I don't mess it up. Okay, so when we look at these, we'll try to find our zeros. 1, 2, 3, 4. This one's in between. So this is 4, 5, 6, 7. So we want to check a 7. And so we'll try second calc value and try the 7. And 7 works by the calculator. All right, and I'm going to see if I can get a value on this one. All right, so because otherwise I'm going to have to do some work. I'm at degree 4. Just knowing 1 0 is only going to get me down to x to the third. So I'm going to see if I can get this one if it's rational. So I am going to do second calc, and I'm going to look for that 0. And I need to get to the left of it. I can enter a value to get to the left of it, or I can move the cursor. I'm going to just say x equals 3. So I just push the 3 in, and it will take that. That makes my left bound. All right, I can move the cursor. I need to get to the right of it. So 3, 4, 5 should be okay. 1, 2, 3, 4. 5 is clearly to the right of it. So I'm just going to enter that. And I'm going to say guess. Enter on guess. All right, so it is giving me a value that can be written as a fraction because it's a decimal that terminates, and it terminates or repeats, then it's rational. Right, so this is 4.5, and if I need to put it in as a fraction, 4 times 2 is 8, and 1 is 9 over 2, so 9 halves. So I have 2 zeros. Then I'll go to synthetic division. I'm going to do the 7 first. -2, 23, -73. And if I make any error, you guys help me out there. That's why I try to work the problems ahead of time so I can avoid making those because the errors happen. Okay. All right, -2 times 7 is a -14. And then we have 23 minus 14 is 9. 9 times 7 is 63. This gives us a -10. Negative 10 times 7 is a negative 70. This gives us 45, and 45 times 7 we hope is 315. Which tells us that's a 0, which is what it should be. All right. Then we'll go ahead and also divide by 9/2 to get this to go lower to get a quadratic. All right, bring down your first one. And so we have negative 2 times 9/2. You can use your calculator or you can do it by hand. They're going to give you ones that divide out nice. Your 2's go out. This gives you negative 9. And very nice, it gives us a 0. 0 times anything is 0. So negative 10. And then we have 9/2 times negative 10. Right, divide by 2. And so 9 times negative 5 is negative 45. And that gives a 0. So very good. These two are working. And now we have a quadratic. We've gone down 2 levels. So we have negative 2 x squared minus 10 because this would have been the plain x term equals 0. I would solve this one with the square root method instead of going to quadratic formula because you don't have a plain x. So add your 10, divide by negative 2, and now take your square root method. So that will say x equals plus or minus the square root of negative 5, which is going to be I times the square root of 5. All right, so our zeros are going to be plus and minus I times the square root of 5, 9/2, and 7. And we'll just check. There we go. They have their I after. I like the I in the front so it's clearly not under the radical. Right, and now they want linear factors out of this. And each of them need a leading coefficient of 1. So let's see if we can go big here. And we're going to have we have to be a little careful. This one is a little tricky. See, they didn't tell us any p of something equals some number to help us figure out the leading coefficient, the a, so we don't have that help. So our factors are going to be x minus 7, that one's good, x minus 9/2, right, x minus I square root of 5, and x plus I square root of 5. Now, if you multiplied this without the a there, it's going to give you x to the 4th. But notice back on our original problem, like we didn't have this on one of the recent ones we did. We had a 1 at the beginning. We have a negative 2 here. So we are going to need, our a is going to be a negative 2 to make this work. So we're going to have a negative 2 times x minus 7 times all this. And it should take this form. Let's go back. And we'll just have a look without typing it in. There's your negative 2. So that's the tricky piece. Just if this is not a 1, you can bring this down. That'll be your factor. So x minus 7, x minus 9/2, x minus I square root of 5, and plus. Right. I'm not sure I have time to finish either one of the other ones. You guys want me to go back and try 13 and I can finish it on the video if we run out of time, or are you good? What's your preference? Okay, so we'll get a new page. So if you have to go somewhere, it's okay to just go out. So we'll go back to 13. That was one I skipped. It's going to be similar to 14. And first thing I would do is I would go to the calculator to try to get some zeros. So we'll enter -4 x to the 4th plus 38 x to the 3rd minus 96 x to the 2nd plus 22 x plus 40. And we'll say graph. Right, and this is the one I changed the scale on a little bit just so I could see this clearer. So I'm going to change the window. All right, and so I'm going to make this smaller here. So I want to see, we'll say just go on x min to -3, and for x max, let's just go to 8. And that was just to blow this up a little bit so I could check these. This one I think is going to be a fraction. We'll check it. It may be in between. We could get some rational ones here. All right, let's check this one first. All right, so this looks to me like a +1, which we'll check. So second calc value. And that one works. All right, 2, 3, 4. It looks like 4 is. And it is. And let's just go ahead and check this next one. But it might not be. It might be a, whoops. Okay, it is an intercept. So that is 3 of the zeros. This is the one we need right here. Let's just use our calculator wisely. So if we do second calc, and we want 0 this time. Okay, that is not what we want. So let's clear. Right. Second calc, and we want to choose 0. choice number 2, enter. All right, and we know these 3, 1, 4, and 5. This is the one that is probably a fraction. So we're going to do left bound. Let's say a -2. So if we just enter -2, this is not right bound. My calculator is doing weird stuff here. I don't want to right bound there. That's clear. All right, so second calc, choice number 2, enter. All right, left bound is what I want, and so we'll put -2. We'll just enter it rather than move the cursor. All right, so that way I'm going to get this 0. All right, and let's choose 0 for the right bound. And then we'll say guess and hit enter one more time. And this one does give us a fraction. So it gives us -0.5, which is -1/2. So we're actually not going to have to do any synthetic division here. We have the pieces to get the roots, so we're going to have x minus 1. And this is one of your answers. This is the second answer. 4, 5, 1, and -1/2. So we're good there. So for our polynomial, we'll leave a space for a. We're going to have x minus 1, x minus 4, x minus 5, and this will have to be x plus 1/2. And then you are going to need a number here, because if these are just multiplied, that's x to the 4th, but in front you had a -4. So bring that -4 down. I'm going to write it here just to have more space. All right, and let's see if that's what they have. -4, x minus 1. Your order doesn't matter because it's all multiplied. X minus 4, x minus 5, and x plus 1/2. And we were able to get all the way through it because it didn't need any synthetic division. So, all right.